Opinions on the necessity and cost-effectiveness of lightning protection systems for new properties vary widely. Firstly, enhanced safety. Lightning can cause fires, electrical damage, and injuries to occupants. A lightning protection system helps to mitigate these risks. Secondly, peace of mind. Property owners can have peace of mind knowing that their building is protected against lightning strikes. Thirdly, building codes. Many building codes and insurance companies require or recommend lightning protection for certain types of structures, such as tall buildings and those in areas with high lightning activity. Fourthly, increased property value. A lightning protection system can increase the value of a property by demonstrating the owner's commitment to safety and protecting the investment. However, there are also cons to consider. Firstly, initial cost. Installing a lightning protection system can be expensive, especially for large buildings. Secondly, maintenance. The system requires regular inspections, testing, and maintenance to ensure it remains effective. Thirdly, aesthetic considerations. Some people may find lightning protection systems to be visually unappealing, especially on residential buildings. Fourthly, insurance deductibles. Even with a lightning protection system, property owners may still be responsible for a deductible in the event of a lightning strike. The decision of whether or not to install a lightning protection system on an 11-floor residential building is a complex one that should be made in consultation with a qualified electrical engineer. Factors to consider include the frequency and intensity of lightning strikes in the area. Secondly, construction type, focusing on the materials and structure of the building. Thirdly, height. Taller buildings are more likely to be struck by lightning. Fourthly, occupancy, including the number of occupants and the potential risks to their safety. Value engineering is a process of reviewing a design to identify and eliminate unnecessary or redundant elements. When considering value engineering for a lightning protection system, the following should be kept in mind. Firstly, assess the risk. Determine the actual risk of a lightning strike based on the building's location and construction. Secondly, consider partial protection. If full protection is too expensive, consider installing partial protection, such as surge suppression devices or roof-mounted air terminals. Thirdly, negotiate with the contractor. Discuss the options for a lightning protection system with the contractor and negotiate a cost-effective solution. The decision of whether or not to install a lightning protection system on a new property is not clear-cut. It depends on a variety of factors, including the building size, location, and occupancy. While it is generally advisable to have a lightning protection system in place, it is important to weigh the costs and benefits carefully before making a decision. Lightning protection systems are designed to provide a safe path for lightning current to flow to ground, thereby protecting a structure from damage. These systems typically consist of air terminals, also known as lightning rods, which are installed on the roof of a building to intercept lightning strikes. These air terminals are connected to a network of conductors that carry the lightning current down to grounding electrodes buried in the earth. The grounding electrodes dissipate the energy safely into the ground, preventing it from causing damage to the building or its contents. The effectiveness of a lightning protection system depends on several factors, including the design and installation of the system, the conductivity of the soil, and the frequency and intensity of lightning strikes in the area. It is crucial to have a qualified electrical engineer design and install the system to ensure that it meets all applicable codes and standards. Regular inspections and maintenance are also necessary to ensure that the system remains effective over time. In addition to protecting the structure itself, lightning protection systems can also help to protect sensitive electronic equipment inside the building. Lightning strikes can generate powerful surges of electricity that can damage or destroy computers, televisions, and other electronic devices. Surge protection devices can be installed at the electrical panel to help protect against these surges. These devices divert the excess voltage to ground, preventing it from reaching the sensitive electronic equipment. There are different types of surge protection devices available, including whole house surge protectors and point-of-view surge protectors. Whole house surge protectors are installed at the electrical panel and provide protection for all the circuits in the building. Point of view surge protectors are plugged into individual outlets and provide protection for the devices plugged into those outlets. The choice of which type of surge protection device to use depends on the specific needs of the building and its occupants. When considering value engineering for a lightning protection system, it is important to carefully assess the risks and benefits of each component of the system. For example, the number and placement of air terminals can be adjusted to reduce the cost of the system without significantly compromising its effectiveness. Similarly, the size and type of conductors used to connect the air terminals to the grounding electrodes can be optimized to reduce costs. However, it is important to ensure that any changes made to the system do not violate applicable codes and standards or compromise the safety of the building and its occupants. In some cases, it may be possible to install a partial lightning protection system instead of a full system. A partial system may only protect certain areas of the building, such as the roof or the electrical panel. This can be a cost-effective option for buildings where the risk of lightning damage is low. However, it is important to carefully consider the potential consequences of a lightning strike to an unprotected area of the building before deciding to install a partial system. Another option for reducing the cost of a lightning protection system is to negotiate with the contractor. Contractors may be willing to offer discounts or alternative solutions that can help to reduce the overall cost of the project. It is important to get multiple bids from different contractors to ensure that you are getting the best possible price. It is also important to carefully review the contractor's qualifications and experience to ensure that they are qualified to design and install a lightning protection system. The National Fire Protection Association, known as NFPA, offers standards for the installation of lightning protection systems. And FPA 780 is the standard for the installation of lightning protection systems. This standard provides detailed requirements for the design, installation, inspection, and maintenance of lightning protection systems. It covers topics such as the selection and placement of air terminals, the size and type of conductors, the grounding requirements, and the surge protection requirements. And FPA 780 is widely recognized and used by electrical engineers, contractors, and building officials to ensure that lightning protection systems are installed safely and effectively. The decision of whether or not to install a lightning protection system on a new property is a complex one that requires careful consideration of a variety of factors. It is important to weigh the costs and benefits of the system and to consult with qualified professionals to ensure that the system is designed and installed correctly. By taking these steps, property owners can help to protect their buildings and their occupants from the dangers of lightning strikes. Consider the building's location, construction type, height, and occupancy when assessing the need for lightning protection. Assess the frequency and intensity of lightning strikes in the area. Data on lightning strikes can be obtained from various sources, such as the National Weather Service and lightning detection networks. The higher the frequency and intensity of lightning strikes, the greater the need for lightning protection. The materials and structure of the building also play a role in determining the need for lightning protection. Buildings made of conductive materials, such as metal, are more likely to be struck by lightning than buildings made of non-conductive materials, such as wood. Taller buildings are also more likely to be struck by lightning than shorter buildings. The number of occupants and the potential risks to their safety should also be considered. Buildings with a large number of occupants, such as schools and hospitals, may require lightning protection to ensure their safety. Similarly, buildings that house sensitive electronic equipment, such as data centers and telecommunications facilities, may require lightning protection to protect the equipment from damage. When considering the cost of a lightning protection system, it is important to consider the long-term benefits. A lightning protection system can help to prevent fires, electrical damage, and injuries to occupants, which can save money in the long run. It can also increase the value of the property and provide peace of mind for the owner. It is also important to consider the cost of maintaining the lightning protection system. Regular inspections and maintenance are necessary to ensure that the system remains effective over time. The cost of maintenance will vary depending on the size and complexity of the system. When negotiating with the contractor, be sure to get a detailed breakdown of the costs involved. This will help you to understand where your money is going and to identify any potential areas for cost savings. It is also important to get a written contract that specifies the scope of work, the payment terms, and the warranty. There are several different types of lightning protection systems available, each with its own advantages and disadvantages. The most common type of lightning protection system is the traditional lightning rod system. This system consists of air terminals, conductors, and grounding electrodes. The air terminals are installed on the roof of the building to intercept lightning strikes. The conductors carry the lightning current down to the grounding electrodes, which dissipate the energy safely into the ground. Another type of lightning protection system is the charge transfer system. This system uses a network of conductors to dissipate the electrical charge in the air around the building, reducing the likelihood of a lightning strike. Charge transfer systems are typically more expensive than traditional lightning rod systems, but they may be more effective in certain situations. Surge protection devices are an important component of any lightning protection system. These devices protect sensitive electronic equipment from damage caused by lightning surges. Surge protection devices are installed at the electrical panel and at individual outlets. It is important to choose surge protection devices that are rated for the voltage and current levels in your building. Regular inspections and maintenance are essential to ensure that a lightning protection system remains effective over time. The system should be inspected at least once a year by a qualified electrical engineer. The inspection should include a visual examination of the air terminals, conductors, and grounding electrodes. The grounding electrodes should also be tested to ensure that they are providing adequate grounding. If any damage or corrosion is found, it should be repaired immediately. In addition to regular inspections, the lightning protection system should also be tested after any significant lightning storm. This will help to ensure that the system is functioning properly and that no damage has occurred. Lightning protection systems are an important investment for any building, especially tall buildings and those in areas with high lightning activity. By taking the necessary steps to protect your property from lightning strikes, you can help to prevent fires, electrical damage, and injuries to occupants. The grounding system is a critical component of a lightning protection system. It provides a path for the lightning current to flow safely to ground, minimizing the risk of damage to the building and its contents. The grounding system typically consists of grounding electrodes, which are buried in the earth, and conductors that connect the air terminals to the grounding electrodes. The grounding electrodes should be made of a conductive material such as copper or galvanized steel, and should be of sufficient size and number to provide adequate grounding. The conductors should also be made of a conductive material and should be securely connected to the air terminals and the grounding electrodes. The soil conditions can also affect the effectiveness of the grounding system. Soil with high moisture content is more conductive than dry soil. Therefore, it is important to ensure that the grounding electrodes are buried in an area with adequate moisture. In some cases, it may be necessary to add soil amendments to improve the conductivity of the soil. The location of the grounding electrodes is also important. The grounding electrodes should be located as close as possible to the building and should be spaced evenly around the perimeter of the building. This will help to ensure that the lightning current is distributed evenly throughout the grounding system. The grounding system should be inspected regularly to ensure that it is in good condition. The grounding electrodes should be checked for corrosion and the conductors should be checked for damage. If any problems are found, they should be repaired immediately. A properly designed and installed grounding system is essential for the effectiveness of a lightning protection system. By taking the necessary steps to ensure that the grounding system is in good condition, you can help to protect your property from the dangers of lightning strikes. The height of a building is a significant factor in determining the risk of a lightning strike. Taller buildings are more likely to be struck by lightning than shorter buildings because they provide a shorter, more direct path for the lightning to reach the ground. The area of the building's roof also plays a role. Buildings with larger roofs are more likely to be struck by lightning than buildings with smaller roofs. The shape of the building can also affect the risk of a lightning strike. Buildings with pointed roofs are more likely to be struck by lightning than buildings with flat roofs. The presence of nearby trees or other tall objects can also increase the risk of a lightning strike. Lightning tends to strike the tallest object in an area. Therefore, buildings that are located near tall trees or other tall objects are at a higher risk of being struck by lightning. The decision of whether or not to install a lightning protection system on a building should be based on a careful assessment of the risks and benefits. The risks should be evaluated based on the building's height, location, and occupancy. The benefits should be evaluated based on the potential for preventing fires, electrical damage, and injuries to occupants. A qualified electrical engineer can help to assess the risks and benefits and to design a lightning protection system that is appropriate for the building. In addition to the factors discussed above, it is also important to consider the cost of the lightning protection system. The cost of the system will vary depending on the size and complexity of the building. However, the cost of the system should be weighed against the potential cost of lightning damage. Lightning damage can be very expensive, and it can also disrupt business operations. A lightning protection system can help to prevent lightning damage and to minimize the disruption to business operations. Therefore, the cost of the system should be viewed as an investment in the safety and security of the building and its occupants.